Hello, everybody. It's lovely to see you all. I hope that you are all well under the current circumstances and that astronomy will provide a welcome distraction for an hour or so. So the title of my talk is There Life in the Clouds of Venus? And that all sounds very specific indeed. But it's all based upon a recent announcement made by the Cardiff group of astronomers who have detected the gas phosphine in the clouds of Venus. And this may indicate that there is life there. But before we start talking about that discovery and the details of Venus, I thought I would introduce you to what is arguably the most considered to be the most amazing or beautiful picture in all of astronomy. And that is this one. And this is what's called the Hubble Deep Field. And the Hubble telescope, as you may know, is an optical telescope, well, also infrared and ultraviolet, but mainly optical. And it has taken this extraordinary picture of a very tiny section of the night sky. And what it shows you is the thousands and thousands of galaxies that are present in just that tiny speck of sky. It's only about 1/20th of a degree by 1/20th of a degree square. And in it, we can see about 10,000 objects, each of which is a city of stars in its own right. And if you look in the top left here, I don't know if you can see my mouse, but you can see this pair of beautiful spiral galaxies. And each one of these is a city of stars, containing hundreds of billions of stars. And if we look at just one of them, this is just a random, particularly beautiful example of a galaxy, which I picked yesterday. And this is NGC 3344. Now, not going to go into any details about this galaxy, but just to show you that this is just one of those galaxies in that image. And it itself contains hundreds of billions of stars, as does our galaxy, the Milky Way. And so the reason for showing you this is to introduce the immensity of the universe and the vast numbers of stars that there are contained within it. And in fact, it may well be infinite. And so the question of, one feels intuitively that the universe must have life in it. This is really what the talk is all about. The most important question that you can address of the universe, that you can ask of the universe, is there life out there, or are we completely alone? And human beings have a deep need to understand their place in the universe. And that's why this announcement of the possibility that there may be life in the clouds of Venus is so important, because if there were life in the planet which is nearest to us, then we could investigate that life much more thoroughly than we can the life that might be present in any of those stars which I just showed you. And it would be a boon for science, philosophy, and no doubt religion as well. Although under the current circumstances, I'm not sure people would be too keen on bringing any possible life back to Earth because of the possible havoc it might create. But nevertheless, it would be a breathtaking discovery, possibly, arguably the greatest discovery in all of science. So let's go now into a little bit more depth about that discovery. So the announcement was made just over 3 months ago in September, and it caused a firestorm of interest in the community and the wider public as well, I would say. And so it sounds very specific and very esoteric, the discovery of a particular gas. But the reason why this gas, which is called phosphine, is so exciting is because in Earth's atmosphere, it is only present due to life. It's either produced industrially, in which case human beings have produced it, and we don't think there are any human beings producing it industrially in the atmosphere of Venus, or it is produced by living organisms. It is not produced, in other words, by other processes like chemistry in the atmosphere, or the action of the sun on the atmosphere, or volcanism, or any other form, or any other mechanism. It is only produced by life. And so if it's in the atmosphere of Venus, perhaps, and it is a perhaps, it is produced by life there as well. The other possibility is that it's produced by some weird chemistry which we don't understand. But chemists and astronomers are very confident that phosphine is very unlikely to exist for that reason in the atmosphere of Venus, especially in the levels that have been detected, which are now considered to be about 4 parts per billion, which doesn't sound very much, but actually it does amount to a considerable amount of the gas. So what the astronomers did was that they already knew that if phosphine was detected in the atmosphere of another planet, that it would be a good indicator that it possibly has life. And so they deliberately looked for this gas and they targeted Venus. And in doing so, they used these very odd looking, these are telescopes, but they are radio telescopes. So we're used to so-called ordinary telescopes being the ones that you look through with your eyes. But the universe emits light at all wavelengths, not just the wavelengths that we see with our eyes. It also emits wavelengths in other bands like infrared and ultraviolet and gamma rays and X-rays, but also radio waves. Radio waves are waves of radiation that have a much longer wavelength than the waves of light that we see with our eyes. And that's why these instruments are so large. And the one on the left is the so-called JCMT, the James Clerk Maxwell Telescope, which is based in Hawaii. And the one on the right is the Atacama Large Millimeter and Submillimeter Array, a group of telescopes in Chile. And both of these telescopes are high up in the atmosphere of the Earth, which helps the observations. And what they were looking for was this. So this is a graphic, and the main picture in the graphic shows the white that shows the atmosphere of Venus, the surface and the atmosphere, the yellow atmosphere. But what it's illustrating is that the radio waves, which the astronomers were looking for, are actually produced in the atmosphere. And the molecules of phosphine, I should say, which are above those radio waves, are vibrating. And the way that which they are predicted to vibrate means that they absorb that radio wave light at a very specific wavelength. So if you look in the panel in the top right-hand corner, astronomers love graphs. And what they have predicted is that if you plot the amount of radio wave light you get at different radio wavelengths, you get a characteristic dip, which is shown by that red line there in the graph. And that dip occurs at a very specific wavelength. It's actually 1.123 millimeters. And it's very specific to phosphine. So if you detect that, you've detected phosphine. And so using those two telescopes, the astronomers measured the dip. Now the dip here is looking, you've got a red dip and you've got a yellow dip, which is faint, so behind sort of merged in with the red. So the yellow measurements, which are the very blocky measurements, were made by the JCMT in 2017. And then what they wanted to do was to try and confirm that result with another telescope, the ALMA telescope, which I mentioned earlier. And that's a more sensitive telescope. And that's why its spectrum is more detailed. And that was done in 2019. So there was a long period of thinking about the results and trying to book time on these very busy telescopes, especially ALMA, very busy telescope, have to wait a long time to get observing time. And once they'd reduced their data, taken the observations, this is what they saw. And therefore they concluded they discovered this gas, phosphine, in the atmosphere. So what about phosphine itself? Well, it's a really nasty chemical, actually. Very, very poisonous. And it is always found associated with life. And when it comes to natural life in the environment as opposed to industrial processes, then it's always found in very niche environments. And they're always environments where there is no oxygen. Phosphine is only ever produced in what's called an anoxic environment without oxygen. And so in the top left here, going clockwise, you see there's swampland. So under the swamp, deep within the swamp, there's very little oxygen, and we find phosphine is produced there. It's also found in penguin poo, not very pleasant, penguin in feces and intestines, but it has been associated with penguins, which has sort of captured the imagination a little bit. In rice paddy fields, bottom right, and in decaying fish. So very smelly, very noxious, very poisonous to humans as well, compound. And hasn't been studied very well for those reasons, but is definitely only associated with life on Earth and is only found in very sort of localized environments. It's not spread uniformly through the Earth's environment. So we're confident that if we find phosphine, it's associated with life. And that's a really important point. So if we look at the orbits of the innermost planets of our solar system, the 4 rocky worlds, we've got Mercury. So the sun is in the center here. These are the arrangement of the planets as we see them today, as they are now. But the point is that Venus is the second planet, and Earth, of course, us, is the third planet. And you can see that the orbit of Venus is the closest to Earth than the other planets. Even though at the moment we are closest to Mars, Venus is on average the closest planet. And that is one reason why it is so bright in the night sky. So here we have a lovely photograph, not taken by me, by Meg Thomas. And it's a picture of the moon, and Venus is on the right here, this very bright star-like object. And Venus really is that bright. So if you're not sure you've seen Venus, you probably have seen it without realizing it, possibly either recognized it as being Venus or maybe an aeroplane or something, but it's exceptionally bright. And being that the closest planet, it's also very reflective as well. So that means that it's the most reflective planet, and it reflects over 70% of the sunlight that's received from it. And it's also relatively large. And these three factors mean that it's very bright in the night sky. The brightest star-like object in the entire sky. And here we have Venus taken by, it looks like it was taken yesterday. In fact, it was taken by the Mariner 10 spacecraft in February 1974, and it's been enhanced since. And this is similar to what you would see if you were to travel to Venus. The contrast is quite high. It isn't quite as contrasty there. Some of the red that you see is actually from the ultraviolet imager on the spacecraft, but nevertheless, it's very similar. And what you noticed immediately is that it's covered in cloud, and that cloud cover is permanent and it is continuous. So when you look through Venus through an optical telescope, you cannot see its surface. And for this reason, it was once considered to be raining there. In Victorian times, the Victorians believed it was raining there the whole time. And if it was covered in cloud, it must be raining heavily all the time. Therefore, it must be covered in swamps and possibly rainforests. And it was, it had dinosaurs and so forth. And actually, nothing could be further from the truth, unfortunately. So the atmosphere is mostly carbon dioxide, which is, as you'll probably know, a greenhouse gas, which contributes to making Venus extremely warm. But because its clouds are so reflective, if it had the atmosphere of the Earth and not the atmosphere that it does, it would actually be, if it had the mass of the atmosphere of the Earth, it would actually be cooler than the Earth on the surface, but actually the opposite is true. So this is a comparison of Venus and the Earth, and Venus has been considered historically to be the sister planet to the Earth because it is so similar in its size. It's about 95% of the diameter of the Earth and about 80% of the mass. But their paths have taken very different tracks. And Venus has ended up a very different kind of planet to the Earth. Unfortunately, it's often known as Earth's evil twin. There's barely an article on the web that doesn't mention that term. But on the left, you see Venus looking very different to the image that I showed you there. And that's because that's a radar image of Venus taken by the Magellan spacecraft, a NASA spacecraft that orbited Venus in 1991, 1990, and took very detailed radar measurements from the surface because the atmosphere is transparent to radio waves. And so the spacecraft was bouncing radio waves off the surface and was able to measure its height and all its features, almost all of its features, which is very important, including all the volcanoes. So that's why that's orange, but it's a radio map effectively showing you the size of the surface. So this is remarkably a photograph of the surface of Venus. And the reason why it is particularly remarkable is that the surface conditions at Venus are extremely hostile. So we find that the surface pressure is about 92 times that of Earth, and the surface temperature is about 465 degrees centigrade. So the surface of Venus is easily the hottest surface of any world in the solar system, any rocky world in the solar system, even hotter than that of Mercury. The reason why that is because the atmosphere is so heavy. So volcanoes early in the history of Venus have emitted a copious amount of carbon dioxide and also nitrogen, as well as water vapor. And that has made the atmosphere very heavy. And so because temperature is related to pressure, not only is the pressure very high because of the mass of the atmosphere, the very high mass, but also the temperature is very high as well. And if the Earth had a similar weight of atmosphere, it too would be similarly hot. But the huge amount of carbon dioxide in the atmosphere, about 96%, makes the temperature even hotter. So that means that this spacecraft, so you see the sort of rim of the spacecraft in the bottom of the image, and you see also one of its camera lenses, which has come off, would have melted and been crushed within about 2 hours of this photograph being taken. So they had to take it and get it back to the Earth in quickly. So breathtakingly hostile conditions. And I can promise you that there will be no life on the surface, or if it is, it would be completely extraordinary. So there's almost certainly no life there. But there could be higher up, as I will describe in a moment. And the surroundings are sort of basalt, which is rock that has come from volcanoes. There are a huge number of volcanoes, 1,600. And although there's no active volcanoes at the moment that are known, there is some evidence this year, but no photograph has ever been taken of an active volcano. Volcanism has played a very major role in the history of Venus. So if we think there is life at Venus in the atmosphere, high in the atmosphere, then how do we think that might have arisen? Well, this graphic, and I hasten to say it is a graphic, is meant to illustrate that early Venus may have been covered in an ocean like the Earth. It isn't certain, but what is quite clear, there's quite strong evidence that Venus had a lot of water early in its history, and that it has lost that water. And you would expect this intuitively, because Venus and the Earth are made from the same collection of materials, they formed in a similar part of the solar system. You'd expect them to be made of similar materials, and indeed their bulk density is very similar. And so therefore we expect them to be we'd expect them to have the same inventory of water as the early Earth did billions of years ago. But Venus went a very different way, and it lost a lot of that water, probably because it has very little magnetic field, and so that it wouldn't have been protected from the solar wind, which blasted away the water vapor high in the atmosphere. And Earth's atmosphere is cooler, so it has what's called a cold trap, and that prevents water escaping quite so rapidly. So if the early Venus was cool enough to have oceans, and that isn't certain by any means, but if it were, then life could have arisen there, because we know it arose in oceans on the Earth and eventually migrated to land. And as Venus lost its water, and as volcanism pumped more and more carbon dioxide and water and nitrogen into the atmosphere, and the surface conditions became more and more hostile, then we think that any life forms would have migrated possibly to the upper atmosphere. And there are professional scientists who take this possibility seriously, and were taking it seriously long before the phosphine discovery. In fact, the great Carl Sagan, who you may have heard of, he produced a paper as early as 1967 suggesting that there may be life in the upper atmosphere of Venus. So Venus and the Earth have gone very different ways, and Venus has ended up a pressure cooker of a world, very, very inhospitable at its surface, whereas the Earth, of course, is very temperate at its surface. And they've taken different paths, but maybe that doesn't exclude the possibility of life at Venus. So this diagram illustrates, now this is a diagram, an illustration of a vertical diagram of the atmosphere of Venus, starting with the surface at the bottom, and just to illustrate broadly the structure of the atmosphere. And so even though the temperature, you see the temperature and the pressure on the right-hand side, and you can see that they both decrease with altitude, broadly speaking. At the surface, as I mentioned, the temperature is breathtakingly hot, 430 degrees centigrade and 92 bar atmospheres at the surface. It decreases as you go up, and as you reach the upper atmosphere, the temperature and pressure must be extremely cold. So there must be a temperature and a pressure which are similar to that on the surface of the Earth, and therefore a possibility that life may be there. And that range is about from 55 to 60 kilometers above the surface. And that is indeed where phosphine was detected by these radio telescopes. So that gives us some hope. So in that temperate zone, the temperature is between about 20 and 35 degrees centigrade. And so it's very temperate. It's very like a nice sunny day here, which gives us hope. And the pressures aren't too extreme either, from about 1 bar to 0.1 bar. And it turns out that life isn't quite so sensitive to pressure as it is to temperature, we don't think. I have to also say that we don't really understand the range of conditions under which life could form, because we've only got one example here on Earth. But nevertheless, it does give us hope that we have identified this rather temperate region. There is a significant but, though, that the clouds of Venus are composed of trillions of droplets of sulfuric acid, and it's extremely hostile. So it's referred to as a hyperacidic environment. And acids, sulfuric acid, is extremely aggressive towards life. Nevertheless, there is some hope. This is a photograph, not a photograph of the atmosphere of Venus, I hasten to say, but of the Dalal geothermal area in Ethiopia. And this extraordinary landscape and also lakes that you see here is the most acidic place on Earth where life has been found. And it's similar to places that you see in New Zealand. Its temperature is about 108 degrees centigrade, very, very high. And it's about 5% dissolved sulfuric acid, but it is mainly water with a lot of dissolved salts, particularly iron compounds, and also the sulfur that you see here, which is the sort of yellow and the sulfur compounds. But the sulfuric acid, and we do find organisms do live here. So there is some hope, but there is also, unfortunately, a significant difference. The clouds of Venus, the droplets in Venus's atmosphere, are mostly sulfuric acid with a bit of water, whereas here we have water with a bit of sulfuric acid. And that does mean that the acidity of the clouds in Venus are significantly more acidic, millions of times, in fact, more acidic. So is it possible that we're mistaken, that it couldn't be life? And so the claim that it might be life is an extraordinary claim. And as Carl Sagan once said himself, that extraordinary claims do require extraordinary evidence. So the scientists want to do everything they possibly can to eliminate the possibility that phosphine is produced naturally, other than by life. And so one question is, could volcanoes themselves produce phosphine? And the short answer is no, because the inside and the atmosphere of Venus, most of the elements that aren't oxygen have actually bound to oxygen and not hydrogen. So phosphine is that each phosphine molecule consists of an atom of phosphine that has bound to 3 atoms of hydrogen, and we call that a hydride. But most of the elements in Venus the non-oxygen elements have bound with oxygen, things like carbon dioxide, sulfur to form sulfur dioxide. Phosphorus itself has formed at least 2 oxides. And then you have the minerals as well, the iron oxides of the surface, the solid surface. They too have bound to oxygen. And to form phosphine, you need, even though you've got high pressures on the surface of Venus, you need much, much higher pressures to form phosphine. So we don't believe that volcanoes could produce phosphine on Venus. And indeed, it's estimated that you would have to have about 10,000 times the volcanic activity of the most volcanically active period in Earth's history. So we think that's extremely unlikely. And phosphine is being continuously created at the moment, which makes the argument even stronger that it isn't volcanism. Or could it have been produced? Could it have been brought to? Could it be continuously being brought to Venus by meteorites? And again, really the answer is no. The amount of meteorites that are believed to land on Venus, which is derived from those estimated for the Earth, is only about 20,000 to 70,000 tons a year. And only a fraction of that will be in the form of phosphorus, and even tinier fraction of that will be in the form of phosphine, a negligible amount. So you would have to have trillions of times the amount of meteorites falling on Venus than we expect. And we don't actually have any meteorites of Venus on the Earth, but we do from Mars, interestingly enough, but none from Venus, unfortunately. So those explanations are ruled out. And so we're forced to conclude that if it does exist, that it must be produced by life. But an important question is, how could it be produced by life if it isn't produced naturally by non-life, if you see what I mean? So if it's not produced by the atmosphere or volcanoes or atmospheric chemistry, how could it be produced by life? Because surely life is just chemistry itself. Well, the idea is this, that there are billions and billions of droplets, as I mentioned, of sulfuric acid within the atmosphere, within the clouds of Venus, but that somehow you have a cell within that cloud droplet. So the cloud droplet is illustrated in mustard, that circle in mustard, and inside that cloud droplet is the sulfuric acid, which is labeled very acidic. But within that cloud droplet, you have the cells that have formed a very powerful membrane that is able to resist the acidity. And inside that cell, you get water, and that water is neutral. So it's like the cells in our body and all living things. So all living things are water-based. All cells in the living world are filled with water, and their pH is neutral. And the complex molecules that life manages to produce, in some circumstances on the Earth, they are able to reduce, they are able to convert the phosphorus chemicals in the atmosphere of Venus, possibly into phosphine, because this is what happens on Earth. And we know that life is able to make these proteins. So there are these molecules, these complex molecules, in a way that non-life cannot. And now this is the explanation why life can do this and not non-life. Life is also able to make an energy investment. So if you imagine that you want to travel to a village that's on the other side of a hill, life is able to get you up to the top of the hill such that you can climb down to the village on the other side. But non-life processes aren't, generally speaking, able to do that. They can only get you to that village if you have a direct downhill route. And so life is able to overcome these barriers, if you like. And this is what is hypothesized must be happening. But it is very, very speculative. And the acidity is a real problem. And this is a bit more detail about the cells themselves that has been published. And it is, again, just speculation. And so you have a cycle here of how life might evolve. Life might exist in the atmosphere of Venus. So again, this is a vertical section through the atmosphere. And you start at 1, and the idea of 1 is that there are cells in a dormant state. So these are called spores. And it's not fully understood, but it's where life can exist in a kind of shut down state, a dormant state. And at this point, the dormant state, the spores, are not contained within the droplets. They're actually contained within the very dry atmosphere between the droplets. But that there is a process which transports them up to the temperate zone between the 2 dashed lines that I talked about earlier, where the temperature and pressure is more pleasant. And when they get there, they can form the seeds of clouds, droplets rather. These are a similar thing occurs on Earth in the formation of clouds. They're called cloud condensation nuclei. So droplets form around these dormant cells at stage 3. And at stage 4, these cells change from being spores into active cells where they divide and reproduce at stage 4. And then they get lifted into the upper atmosphere, and then the droplets themselves coagulate. So we know this. We know that the droplets in the atmosphere of Venus group together and become larger and larger. And so they become heavier, and so they drop out of the atmosphere. And that's what you see in stage 5, where you've got these cells that have reproduced. As they fall, the temperature rises, the cells go back into a dormant state, which is stage 1, and the cycle reproduces. It is lossy. You lose some cells at the bottom, which is that arrow curled down to the base, and at the top as well. But you make up for it because you're ending up with more cells in stage 5 than you were in stage 1 to 3. So this is an idea of how life could exist in the atmosphere of Venus. So there is other evidence which is most interesting, that is very much circumstantial, definitely not proof, but it adds to the story, and that there possibly is life there. So it's not just the detection of phosphine. There is something in the atmosphere which is what is called an unexplained ultraviolet absorber. So what that means is that the sun is shining down very powerfully on Venus with a strong ultraviolet light. And Venus doesn't have an ozone layer, so it doesn't absorb that ultraviolet light high in the atmosphere. It descends lower into the atmosphere, and it could provide a very powerful energy source for the bacteria, by the way. But what I'm showing you here is that there are these there are lots of patches in the atmosphere which are unexplained, and a great deal of effort has gone into explaining them. Various chemicals have been considered, such as ferric chloride and different forms of sulfur and so forth. But although this is understood, it's not known which chemicals are producing this. And they also behave in a rather strange way. They vary in space and over time in very unusual ways. And so this is possible. Some people have suggested this is actually the algal blooms. So we get algal blooms near the surface of oceans on the Earth that spread very rapidly and change over time rapidly. And it's thought that, it's been speculated, and it is speculation, this is also the putative life in the atmosphere of Venus as well. And finally, there is a bit more detail. So I actually had to take this from the Sky. There's a Sky at Night program on the discovery of phosphine, with a very excitable Chris Lintott talking to a very happy Jane Greaves, who was the primary discoverer. And I took this screenshot from the program. And the reason for me doing that was that the spectrum that the measurements that they took, that I showed you earlier, are that blue line on the right-hand side, that blue line with the dip. But if you do the same measurements at the poles, the north and south poles, you find that the dip is not so pronounced. And the idea is that life, the bacteria, are circulating in the atmosphere. So on the right-hand side, it's a bit complicated, but if you draw a cross-section of the planet and the sun is on the left, the sun's heat and energy radiation is driving the circulation of the atmosphere. So the upper atmosphere is rotating to the other side. It's also rotating in lower depths. And so the idea being that if there is life, it's being transported in this way. And you would expect it to be more prominent, therefore, at the equatorial regions that are near the equator than you would be at the poles. And that seems to be backed up by the measurements. So that's another piece of very circumstantial evidence, certainly not proof, but interesting nonetheless. So this is quite a different slide, and this is meant to illustrate that human beings are very passionate creatures. And there is a cliche that scientists are impassionate observers of the world, simply recording what they see and publishing what they find in journals. But in reality, nothing could be further from the truth. They are human beings like you and I. They can adopt positions which they feel very strongly about. They often base their careers on taking a particular position, which is perfectly understandable. And also understandable is that they can sometimes feel threatened when their position is apparently, as they may perceive it, under attack or criticized by somebody else. Of course, criticism is an essential part of science, and all scientists recognize this. But nevertheless, we are all still human. And there has been a bit of a spat, shall we say. So there are a few topics in astronomy that incite greater passions than the question of life. And the community is somewhat polarized as to whether life is on Venus or not, and each position is strongly held. So what happened as soon as the paper was published is that quite quickly they were criticized. And they were criticized by the governing body of astronomy, the International Astronomical Union. And a particular committee of that, IAU criticized the main authors of the paper for being too open that it might be life, being too suggested that it might be life. And a lot of people disagreed with them, including the IAU themselves. So the IAU wrote to the committee saying, excuse me, I don't think you should be saying that. So they immediately apologized and retracted that statement. And then there was a paper published saying that actually you haven't discovered phosphine, you've discovered sulfur dioxide. And they even suggested in their abstract that the original authors ought to retract their paper, which is quite an incendiary thing to say and was considered to be going too far. So they had to retract and apologize as well. Since then, there have been papers supporting the findings. So there's been a paper, actually only one that I'm aware of, which has looked at historical data from the Pioneer Venus, because there have been many missions to Venus, especially by the Russians and also the Americans. And some of these have actually dropped probes into the atmosphere, and the Russians have even floated balloons within the atmosphere as well as successfully landing ultimately. And that study said that actually we've looked again at this data and we think there is phosphine there as well as fragments of phosphine. I should admit to you that the people who published that paper are pro-life in the atmosphere of Venus. So we haven't yet got to the situation where somebody who was anti-life has become pro-life or the other way around. So the positions are still very polarized. And there have been also 2 papers which have said that the original discovery is mistaken and that the way that they have reduced their data, because there's a lot more to astronomy particularly, a lot more to science, but astronomy in particular, than just observation. You have to convert your results into something that has meaning. You have to remove the noise and you have to account for the vagaries of the particular instrument that you're using. So those papers have actually criticized the claim at all, and they are, I would say, depressingly convincing, but they haven't, I don't think they've proved that for both telescope results. And the original author, the latest paper, which was released about a week ago, just over a week ago, I think, said that actually it isn't sulfur dioxide, we really have discovered phosphine. So they haven't defended themselves against all the criticism yet, but they are still strongly of the belief that it is phosphine. And what we really need in the short term is more observations. So you may remember that I showed you that phosphine absorbs in the radio at 1.123 millimeters, and that's the radio part of the spectrum. But it is by no means the only prediction. And phosphine is predicted, like many other molecules, to absorb also in the infrared part of the spectrum. So that is like light, but slightly longer wavelength. And so what we really need is measurements of that infrared radiation to look for more absorption lines of phosphine. And so in the near term, there will be these measurements, or hope to be. COVID has delayed things somewhat. So on the top left, you have a remarkable instrument that's called Sophia. It's the stratospheric observatory for infrared astronomy, and it consists essentially of a jumbo jet with a hole cut in the side. You can just see the aperture here. There's a window there, and inside they've converted the jumbo jet into an observatory. So there's an infrared telescope in there, which can get high in the atmosphere, because unfortunately our atmosphere absorbs infrared radiation, which was why telescopes are very often very high. And it will make further measurements of the infrared radiation to try and back up this discovery. And similarly with the Gemini telescope, you see bottom left. On the right-hand side, there is a spacecraft at the moment on its way to Mercury. It's very difficult to get to Mercury, primarily because Mercury is very small and it's near to the sun, which is very massive. Excuse me. So, what Bepi-Combloux does in order to get there, it does 2 bypasses of Venus. Venus helps it on its way by changing its trajectory and speed. So it passed by Venus late last year, but that was too short notice for it to do any measurements. But early next year, I think actually it's about August, it has an instrument that is capable of doing infrared measurements of the atmosphere of Venus, and it is hoped that it may provide more evidence, one way or the other, of whether Venus is in the upper atmosphere of Mercury. So that's in the short term. In the long term, we want to send spacecraft there, and we want to do so we can get measurements up close. And we really need more landers as well, but it's extremely challenging to land on the surface of Venus. This is where Mars we're much more successful with Mars, and we get many more spacecraft have been to Mars for that reason. But there are 3 spacecraft that are in the pipeline, supposedly, for Venus, but it's not certain whether all 3 will occur. So Chakrayan-1 is an Indian Space Research Organization, orbiter organization I work with quite a bit. And it's supposed to have an orbiter launch in 2025, but it isn't very far down the line yet. So that's probably quite optimistic. But it has got a significant amount of payload mass, 100 kilograms, 4 instruments. Veritas is a NASA orbiter. That's probably the most likely of the 3 to actually happen. Likely to launch in 2026, and it's due to be a radar. So it's a bit like Magellan, but doing better measurements of the surface. But also it has an infrared spectroscope on board, which will be able to take these infrared measurements as I mentioned earlier. And there's Venera D, which is a Russian, the Roscosmos space agency, which is meant to be in collaboration with NASA to produce an orbiter and a lander. But it was first proposed nearly 18 years ago, nearly. And it's been through a lot of issues. It's been redesigned, and funding comes in bits and pieces because of the rather dire economic situation of Russia, no doubt. So apparently the people building it are not even sure as to whether it will actually go ahead or not. So it takes years and years to get these things to work for initial studies. There are other proposals, but I haven't researched those too much because it's very uncertain as to which, if any, of those will actually make it to flight. But just to say that we do need to go back to Venus, but it will be years. It will be probably of the order of 10 years before we're able to do real measurements that are interesting with respect to phosphine. But before that, we need to build up the case for phosphine with telescopic measurements that I mentioned in the previous slide. Excuse me. So to sum up, if we were to discover life in the atmosphere of Venus, it would be a complete game changer. It's almost impossible to exaggerate the scientific significance of the discovery of life, and many people would consider it to be the greatest discovery of all, which is why, of course, it's so interesting and why it excites the greatest passions of the people in the field. And so there are really, if it is life, and it's a very big if, I should say, there are 2 possibilities. Either it's completely an independent genesis of life from the genesis of life that we have on Earth. We know there's only a single genesis of life on Earth. We are all related to each other. Every living thing is. If Venus has gone a similar way and there is an independent genesis of life to that of Earth, then we would be forced to consider that life is everywhere in the universe. And the reason for that is the chances of life only having arisen on 2 planets in one solar system is effectively nil, because of the billions and billions of galaxies, possibly infinite number, and the billions of stars within those galaxies. And we know that most of those stars have planets. It's just unconscionable that that could be the case. So therefore, if life is independent on Venus, then life must be surely everywhere, even if it's not as sophisticated as life on Earth. Or the alternative is that life is related to Earth, that actually we would discover it's not an independent genesis, but somehow it either started on Venus and traveled to Earth and seeded life on Earth, or the reverse. But even so, that would be extraordinary, that life can actually travel between the planets, and it would give us hope that the same thing had happened on Mars as well, this is called pangenesis or panspermia, and it's an idea that goes back decades. First proposed by Fred Hoyle. He was mocked for doing so, but it's still a seriously considered idea. Nevertheless, it would be an extraordinary discovery. The alternative is if there is some bizarre chemistry going on, in which case we will learn something that we don't know about Venus. And the most banal hypothesis is, of course, that perhaps it's a mistake. But we will see. We will know that very shortly. So that really is the sort of picture I wanted to paint of this discovery of phosphine in the atmosphere of Venus, and that there is much excitement to come, and it will be very interesting to see how the debate unfolds in the coming year. Thank you very much.